Hi everyone, I'm Leo and I'm going to be leading you through this tutorial on the anatomy of a PyGMT figure. So let's start with our notebook, Jupyter Notebook, and I'm in Jupyter Lab here. And we're going to be looking at how to build a PyGMT figure from scratch. So first thing we have to do with any Python module is import it. So with PyGMT, we can run import PyGMT. And this one import gives us access to the entire PyGMT library. So everything that's on there for creating figures, for making maps, and also for data processing. So let's execute this with Shift-Enter. So now I have PyGMT at my disposal. And the way we work with PyGMT figures is by first creating a blank figure object. So I'm going to say, let's create a variable called fig. And this is going to be equal to pygmt.uppercase figure, right? So the first uppercase letter there is very important. And open and close parenthesis. So this gives us a PyGMT figure, which you can think of as a blank canvas on which we can start piling on our plotting elements. Right, so everything that's related to plotting in PyGMT is usually done through the fig, the PyGMT figure class. So one of the first things you might want to do if you're doing mapping of any sort is to draw some coastlines of a particular region, right? And that's often a base map that you have to lay down before you can start putting on your data. So to first draw the coastlines, before we can do any of that, we need to define what the bounding regions of our study area are. So we need to know the east, the west, the south, and the north coordinates so that we can start drawing the figure, right? And in PyGMT, that's often going to be referred to as the region. So let's say that the region is going to be a list with the west coordinate for our study area, and we're going to be looking at Japan for this example. So let's do 125 degrees of longitude until 155 degrees of longitude, so west and east. Then the south boundary at 30 degrees latitude and the north boundary at 55 degrees latitude. Okay, so when I run this, now I have a list called region that has the boundaries of my map area. So once I have that, if I want to lay down coastlines on my blank figure, I can do fig.coast, right? And the coast method of fig, of the PyGMT figure, is what controls coastlines and plotting things like that. So what I need to tell it is that the region is region, right? Or the contents of the variable region. And I want it to draw shorelines, right? So I can say shorelines equal true, right? And the true value here tells it to draw shorelines with the default configuration for line lengths and things like that. So let's run this. So that lays down coastlines on top of my blank figure. So once I have that, I kind of want to see what my figure looks like, right? In a Jupyter Notebook, I can do fig.show. And this is going to generate the figure as a PNG and insert it into the notebook. Right? So there I can see the coastlines here of Japan and North and South Korea and China and Russia and all around there. Right? So that displays the figure, but I can still keep laying things on, keep laying plot elements on top of the figure. Right, so the next thing I'm going to do is, well, let's try to color the water blue. Right, so if I want to do that, I can call fig.coast once more. But instead of asking for shorelines, I'm going to ask it for water. And I'm going to give it a color for the water content. So to do that, I'm going to make a string. And I'm going to give it one of the many GMT color values. So for this, I'm going to go with light blue and run that. So I'm going to lay that on the map, and then I'm going to do fig.show. Right, so when I run this, now I have my coastlines from before, but now all the water has been colored blue. So okay, so let's see if we can color the land in green as well. All right, so to do that, I'm going to say fig.coast once more, but instead I'm going to say land equals light green, and then fig.show once more to get a preview of my figure. All right, so now one thing you may notice is that my black shorelines are no longer appearing. And that's because PyGMT doesn't work like other tools like matplotlib. Instead, it lays down plot elements on top of a canvas. And it lays things down in the order in which you call the commands. So since we called first to plot the shorelines, and then we plotted the water in blue and the land in green on top of it, so the shorelines are still there, but they're just underneath the solid color. So to get what we actually want, we need to call things in the right order, right? And also notice that I only need to provide the region on the first argument, and PyGMT will know to reuse that region on subsequent calls, so I don't have to keep passing the region all the time. So if we actually want the shorelines to appear on top of the colored blue and green, we need to call things in the correct order. So I'm going to make a new figure here. So let's say fig equals pygmt.figure, uppercase figure. Then I can say fig.coast, and then I'm going to give it the region equals region, and the land equals light green, right? And instead of calling it twice, I can put it all in one command here, right? So the land in light green and the water in light blue, right? So I'm giving it multiple arguments. Then I can call fig.coast once more, and now I can say shorelines equals true. So this is going to appear on top of the light green and light blue water and land. And finally fig.show. Right, so running this gives me what I actually wanted, which was the shorelines on top of the colors. Now you may have noticed that we can give multiple arguments to coast and it'll plot things in order. So let's see if we can copy all of this over here. And instead of providing shorelines equal true here, I'm going to do it all in one command. Right, so shorelines equal true. And let's delete this line. So when I run that, I can see the shorelines on top, and that's because PyGMT is smart enough to know that the shorelines should appear on top of the colored green and blue water. Right, so yeah, so it's easy to forget that things are laid out in the order in which you call them, but you have to keep that in mind. So if you want to switch the order of things in your plot, you have to call the different PyGMT functions in different orders. Okay, so that's all well and good, but what good is a map without a map frame, right? So that I know the coordinates of the area. So let's draw a map frame. Okay, so to do that, we're gonna once again recreate our figure, right? So let's copy this so that we don't have to write it out again. And after I lay down my coastlines, my shorelines, and my colored land and water, I want to lay down a fig.basemap, which is, amongst many other things, it can draw a map frame around your map. So I'm going to say basemap, and I'm going to say frame equals to the string A. And we'll talk about what that means. So when I run this, now on top of everything I've plotted, I also have this little map frame that has the coordinates. See that it already recognizes that these are longitude and latitude, so it has them formatted nicely. And the A here means that I want to have automatic annotated ticks, right? So these are the annotated intervals that we have here. But what if I want to have minor ticks as well, right? So I want to have the intervals, but without the annotation. So if I want to do that, I can copy all of this. Right, so A is the shortcut for automatic annotated ticks. F is the shortcut for minor ticks. So if I say AF, I'm going to have both the annotated and the minor ticks automatically drawn. Right, so now notice that there's I still have my normal annotated ticks, but I also have a minor interval here for every 1 degree. Okay, so what if on top of that, so let's copy all of this. So what if on top of that, I also want to have grid lines, right? Because those are often useful when you're trying to pinpoint the coordinates of a particular thing. So the command for that is to add in the frame, to add G, right? So G is for automatically assign grid lines on the same spacing as the, same interval as the automatic ticks, or the annotated ticks. So when I run that, so now every time I have an annotated tick, I also get a grid line plotted there. So one final bit of embellishment that we can make is adding a title to my figure. And that's also controlled by the frame argument. But now for frame, we need to give it more than one argument, right? So I am having it control the actual map frame, but I also want to put annotations around it. And that to give frame multiple arguments, I need to pass it a list instead of a single element. So I'm adding a list here. So this is plotting a map frame with automatic annotated ticks, automatic minor ticks, and automatic grid lines. And a second argument to frame that I'm giving is going to be another string, right? And the code here for adding a title is +t. And whatever comes after +t is the title of the figure. So in this case, let's call this Coastlines of Japan. All right, so let's run this. So now I have a nice figure title with a decent spacing so that you can have tick labels on top and all of that. Okay, so all of this in just a few lines of code. Okay, so all of this is nice, but as anyone who plots data on maps will know, when you're plotting things with geographic coordinates, you need to perform some sort of map projection. In the case here, PyGMT is doing a Mercator projection by default. But if you're working in with large extents or with large variations in latitude or further north, you might not want to do a Mercator projection. PyGMT lets you control the projection, and there's several built-in projections. There's a link here in the notebook that you can follow to go see all the projections that are available. But all of this is controlled by the projection argument that we can pass to any PyGMT command. Right, so I'm gonna, for this example, we're gonna use the Cassini projection. And the way we're gonna write this out is, let's go here in coast and let's break the line so that it's not too big. All right, so I'm just gonna put a few blank lines here. All right, and beside everything that I've already given it, I'm also gonna give it the projection argument. Right, and projection is gonna be a string. And it's a string composed of 3 parts. Right? The first part is a 1-letter code for what the projection is. So I'm going to say C for Cassini. And in the PyGMT documentation, you can find out all the letter codes for all the different projections. The second thing I need to give it is the central longitude for this projection. So let's say 140, which would fall right in the middle here of our map. Then I'm going to do a slash in the central latitude, which let's say 40. And finally, I need to say the size of the map in physical units on the paper canvas that we're drawing on. So this is going to influence the size of the relative size of font sizes and tick labels and line thicknesses. So in general, 15 centimeters is a good figure size to have the letters not appear too small. So let's run this now. So if I've done everything correctly, now we automatically have our map of Japan, but in a Cassini projection, which is good for this sort of plot when the geographic features are kind of elongated in latitude. Right. So here we have Japan, but in the Cassini projection, everything else is kind of automatic. So finally, we might want to add some data to the map, right? So let's get some earthquake data that we have built into PyGMT that makes it easy to download. So let's do data equals pygmt.datasets.load sample data. Right, so this is going to download to your computer and also load in a pandas data frame one of the many PyGMT datasets that are available. So for this one, we're going to say name equals Japan underscore quakes. And let's put data by itself. All right, so that downloaded to my computer the Japan quakes data set and opened it up in a pandas data frame, which I can see here. So there's the year, the month, the day, the longitude, the latitude, the depth, and the magnitude of these earthquake hypocenters around Japan. All right, so let's try to see if we can add the hypocenter locations to the map, right, that we had, so that we can see where these earthquakes occurred. So I'm going to copy my plotting code that I had from before, paste it here, and now since I want them to appear after the coastlines, then I'm going to have to put the call here in between. So after I plot the coastlines, I'm going to plot the locations. And I'm going to use fig.plot to do this plotting. All right, so what I need to give plot is what goes on the x or the horizontal axis, and this is going to be data.longitude. Longitude. On the y-axis, I'm going to have data.latitude, and let's leave it at that for now. So let's run this plot. All right, so what we see is that PyGMT by default is going to connect the points by lines, and that's what it draws. So I don't really want that for this data set. I wanted to plot, let's say, circles. So to tell PyGMT to do that, I'm going to give it the style argument to plot, right? And style is also going to be a string, right? And the format is a one-letter code for the symbol. So in this case, I want C for circles. And I also need to provide the size in physical units of the circles. So let's say 0.3 centimeters, since I have a 15 centimeter wide map. Okay, so let's do this. All right, so now I got a bunch of transparent circles, right? If I want these circles to be colored, I can include the color argument, right? And let's say color equals white. And instead of having the transparent circles, now I have white colored circles, right? So now I can see that all the earthquakes are happening here along the subduction zone, which is not entirely surprising, but I also have some other earthquakes here. So I'd be interested to know if these are, for example, deeper. Are they happening on the plate that's subducting? So in order to figure that out, let's see if we can add color the circles by the depth of the earthquake instead of just color them all white. Okay, so let me copy all of that. So if I want to color them by the depth, I can give here color equals data.depth in kilometers, but I also need to first create a color palette table or a color map for PyGMT to use that maps the depth values to a particular color according to a color map. To do that, we run pygmt.makecpt. Right, so this is the program, the function that does this sort of mapping. So I can say cmap equals to one of the many color maps that PyGMT has available. So for this one, I'm going to use the plasma color map from matplotlib. And I also need to give it the series argument, which is a list of the minimum and maximum data values. So here it's data.depth kilometers.min and data.depth kilometers.max. All right, and close. And finally, I need to tell plot that to automatically pull the color, the CPT that was generated with the previous command. All right, so that's why we need cmap equals true. So by running that, now the color is being taken from the depth and it's being mapped onto colors from the plasma color map by pygmt.makecpt. Right, so that's what we see here. So we got different colors depending on the depth. But this is no good because I don't know what this blue means. I don't know what the yellow means. Right, so to do that, we need a color bar that tells us what each color represents. So let's copy all of this. So the final thing I want to lay on my map, right, is a fig.color bar that's gonna add a default color bar to the bottom of my map. Right, so let's run this. So that adds a color bar, and by default it's not super useful, but we can control the frame of the color bar with the tick labels and everything the same way that we do for the whole map with base map. So we can say frame equals, let's say A for automatic annotated ticks, right? And that gives us now nicely automated annotated ticks. So we got a nice progression here of depth in kilometers. And if I want to give it, let's give it multiple arguments. And the second argument I'm going to give it is y plus L depth space bracket km, or let's do parenthesis km. Right, so this is telling that on the y-axis of the color bar, I want to add the label depth kilometers. So when I run this, now I get my color bar, and on the y-axis of the color bar, I get depth in kilometers as a nice label. All right, so with these few commands, we managed to make a figure that follows a projection, includes coastlines, colors, data, and all of that with a color bar. And hopefully this shows the power of GMT. So there's much more that GMT can do, from plotting grids to even doing some 3D plotting that you probably want to check out. So I'll let my other co-hosts of the tutorial to teach you that. And thank you.